In this video, we solve problem number 2 from quiz number 1 from the spring 2021 semester in the elementary differential equations class. We're asked to verify that the given function is a solution of the differential equation. We have this function, we have this differential equation. Remember, if we're asked to verify it, that means we already know that this is a solution to the differential equation. So that just means that if we take the first and second derivative of this and the function itself and we substitute into the left-hand side and simplify, we should get the right-hand side. So in order to verify that that's true, I will compute the first and second derivative and then we'll substitute it in. Now, to compute the derivative for this expression here, we're going to have to use the product rule. We've got a function of t times a function of t. Now, according to the product rule, the derivative of a product is the derivative of the first function times the second function undifferentiated plus the derivative of the second function times the first function undifferentiated. And then we'll add the derivative of t squared, which is 2t, by the power rule. You bring the power down, multiply by t to the 1 less power, and then we'll add the derivative of -2, which happens to be 0. So that's our y prime. It's just not simplified. And to compute the derivative of this, we have to use the chain rule. We have a function inside of another function. The derivative of a constant times a function is that constant times the derivative of the function, and the derivative of e to some power is e to that power times the derivative of the inside by the chain rule. The derivative of 2t is just a 2. Similarly, I've got a cosine of 3t over here, so that's my inside function. So we're applying the chain rule again. We take the derivative of the outside function first. Derivative of cosine of a function is negative sine of that function. You put the inside function back in, and then you multiply by the derivative of the inside. So that's our answer. It's just not simplified, so let's simplify it from here. So this is going to give us a -8 times e to the 2t times cosine of 3t. Then I have a -3 times a -4, which is +12 e to the 2t times sine of 3t. And we're adding 2t to that. Now at this point, you could leave it alone and then just use the product rule for this and this if you want to. Actually, I think I will. I think I'm going to do that. Let's compute the second derivative. If you want to, you can avoid using the product rule twice by factoring out an exponential from both of these and only using the product rule once. I think for simplicity, for most students, it's just simpler to use a product rule here and use the product rule here and then collect like terms. So that's what we're going to do. This is my first function and this is my second function for my first product rule. This is my first function and that's my second function for my second product rule. And that, we don't need the product rule at all. Okay, so we're taking the derivative of this. We have the derivative of the first function. Derivative of a constant times a function is -8, or is that constant times the derivative of the function. And the derivative of a function, derivative of e to some power, is e to that power times the derivative of the inside by the chain rule. Derivative of 2t is just a 2. So that's derivative of the first times the second. And then we're going to add, we're still here, just focus right here, derivative of the second. The derivative of cosine of 3t is negative sine of 3t times the derivative of the inside. Derivative of 3t is 3. That's the derivative of the second. Don't forget to multiply it by the first function. And I've got a lot of colors here, but this is the derivative of the first times the second plus derivative of the second times the first for that first expression, and we'll simplify in a little bit. Now we want to add the derivative of this product. Again, derivative of the first. We bring the 12 down. Derivative of e to some power is e to that power times the derivative of the inside. Derivative of a constant times t is just your constant. That's the derivative of the first. And then we're multiplying by the second. And then we add the derivative of the second. Derivative of sine of some function is cosine of that function. Times the derivative of the inside by the chain rule, that's a 3. That's the derivative of the second. And then we have to multiply by the first. And you might put that in parentheses just to remind yourself that that's not multiplying the 3t inside the cosine function. I know this is messy again, but that's the derivative of the first times the second plus the derivative of the second times the first. Okay, and then we have the derivative of a constant times t, which is just our constant. And we'd like to simplify. So I'd like to group the cosines and the sines together. I want a cosine term and then a sine term. So I've got negative 16 times the exponential times the cosine over here, and a positive 36 times the exponential times the cosine over here. Negative 16 plus 36 is going to be 20 e to the 2t times cosine of 3t. Now here and here, I have a negative 3 times a negative 8 is positive 24 times the sine function times the exponential. And I have another positive 24 times the sine function times the exponential. 24 and 24 is going to give me 48 of those. Okay, and that's our y double prime. So now I've got my y, I've got my y prime, and at my y double prime. I'm going to substitute those into the differential equation. Now we have lots of different forms of these, but I'm going to use this one at the very end. So I'm going to use this for my y double prime when I substitute. I'm going to use this version for my y prime when I substitute. And then I will use, of course, the original y when I substitute. So we've got a lot going on here. Just keep, that's what we're substituting, that and that and that. Let me write the differential equation down again. Now, if I were to add all of these in line, we could do that and it would be fine. But to help with the bookkeeping, I recommend that you add vertically. So rather than doing this and then taking -4 and multiplying it by that, which has multiple terms, and then adding 13 times the original y, which has multiple terms, and then simplifying and then looking for like terms, I'm going to collect like terms in columns as I go. So I'll put y double prime on this line, and -4 times y prime on this line, and positive 13 times y on this line, and I'll add vertically. And my hope is that when I add vertically, everything will cancel and I'll just be left with this second degree polynomial in t. So I'll put y double prime right here. Then when I add, I'm going to put like terms in columns. So I'm going to put my exponentials times cosines over here, my exponential times sine terms here, constant terms here, and then maybe t terms, and then t squared terms. So on this line, I want -4 times y prime. So it's -4 times this. -4 times -8 is positive 32 times the exponential times cosine. And then I have negative 4 times positive 12 is negative 48 times the exponential times the sine function. Negative 4 times positive 2t is negative 8t. And then I want 13 times y, where this is my y. 13 times negative 4 is the same as 26 times negative 2, so negative 52. Excuse me. Times the exponential times cosine of 3t. And we want 13 times this and 13 times that. Well, I don't have a t squared term, so I'll add 13t squared there. And 13 times negative 2 is negative 26. So when we add like terms in the columns, got positive 52 of those minus 52 of those, so those are gone. And these reduce, which is nice. And then this becomes a negative 24 minus 8t plus 13t squared. And that is the right-hand side of the differential equation. So this is the left-hand side, and it equals the right-hand side. It checks out. So we'll say since the left-hand side equals the right-hand side, y equals this function, is a solution of the differential equation.